Okay, so tomorrow, you guys are gonna have some chance to do a little work in here, but here's the other thing that's gonna be going on. One at a time, I'm gonna call you up and I want you to verify that you know how to do all these things. And this counts as an assignment. All you gotta be able to do is just show me you can do all this stuff and you get 100%. Probably one of the easiest assignments you'll have ever, right? So let's make sure though that everybody can do this stuff, right? So you want to be able to log into Moodle and go to the Algebra 2 homepage. I'm assuming everybody's okay with that. Right, you go to, oops. Oh, you know what, we gotta do one thing real quick. Okay, so, in Moodle, you just go to the Moodle address, math.pendleton.k12.or.us. If you need to take any pictures of anything, do that. There's the web address if you need it. Hopefully you've got it bookmarked and you can find it. So you go there and you click on Algebra 2, and that takes you to the Algebra 2 homepage. Which looks like this. And for you guys, it's going to look more like there's only really a couple things you can see. Okay, it looks like that. So then what? You got to be able to go there. You have to be able to show me the homework due dates on the calendar. Okay, so a quick reminder. Here's the calendar, right? If you click on, I got to go back to me. If you click on the calendar, now you can hover over the dates to see due dates, but it's better to just click on it. So if you click on the calendar, you can see all the due dates. I've changed a couple due dates. I assume that I've heard some people maybe weren't 100% certain going into the weekend how to find everything, so I'm cutting you a little slack. The first assignment won't technically be due until tonight. Okay? The second assignment, the 1.2 assignment, won't be due until tomorrow night. And then the stuff we're going to talk about today, that'll be part of a new assignment that won't be due until Friday. So you got a little time on everything, okay? But you got to show me that you can get to the calendar so you can find when everything's due, okay? That's the first part. Next issue. You got to be able to show me, you got to be able to go to the homework assignments and open a homework assignment. So for you guys, that would mean you're going to go down to Unit 1. Right, that's our only unit we've got so far. Click on Unit 1, and it opens it up. And there's Section 1.1, there's Section 1.2, and there's Section 1.3. And that's all that you can see. Those are the only three. Today we're doing 1.3, but last week we did 1.1 and 1.2. Okay? So if you want to go to, for example, a homework assignment, you would click on, remember, the homework assignments are the ones that look like the Moodle assignments have the icon of a blue piece of paper with an orange check through it. And yours, with the ones that you'll have access to, would be the ones that start with an A for Algebra 2. So you could click on this one, for example, A 1.2 Practice 1, and just continue the last attempt. I've already started it. And then just get to the homework assignment. That's the other thing I want you to be able to do, okay? After that, open a homework assignment. Then the fifth thing I want you to show me is that you can find all the resources. So I want you to be able to find the textbook resources and the instructional videos and notes. So where do we find those? So inside Unit 1, remember that when I say the textbook resources, that's just all the stuff in that section above the assignments. So for section 1.2, you've got this link to an online textbook, and then you've got the handout and the handout with answers. Those three things that's your textbook. So you got to be able to show me where those are. It's just the stuff right above the assignment. Okay? And then what about last part? The instructional notes and videos. So you go back to the Algebra 2 page. Oh, you see how I did that, by the way? At the top, you can always see this breadcrumb trail of all the places, where you are. So you're in the Moodle, inside the dashboard, you're in My Courses, and you're in Algebra 2. You can always, if you just go click back on that Algebra 2, that's the quickest way to get back to the Algebra 2 homepage. Okay? So the instructional videos and notes, that's going to be in this top block. instructional videos and notes, and then what you'll see when you go in there it'll just look like this. Right, you'll see down here under Algebra 2 instructional videos and notes, you'll have a link to the instructional videos that you can click on and a link to the instructional notes that you can click on. Okay? Show me that stuff, you got 100%. That's it. Okay? Questions? Easy enough? Good. All right, so for today, just going to do a little bit of review. But today's a real important day. This stuff is not very hard, but it sets you up to be successful when we get into harder material. So we're going to talk about solving equations. On the handout, this is just a copy of the handout that you have. In the upper left, it gives you just a little reminder about the basic steps to follow to solve equations. You know, things like distribute, simplify by combining like terms, for example. Move the variables to one side and then solve using inverse operations. Okay, that's not bad, but I'm going to give you a much better way to think about it. Here's a better way. We're just going to think about it in terms of order of operations. And this is so useful. You'll get amazing amounts of mileage out of this one simple idea. It'll take you all the way through calculus and beyond with solving equations. Very, very useful. So last week we talked about if we want to simplify expressions, we just do regular order of operations, top to bottom, right? But if we want to solve an equation or isolate a variable, we reverse the order of operations, right? We go backwards through the steps. That's what we call inverse operations. So that'd be solving or isolating a variable. Same thing, okay? So here's the way we're going to do this. You're always going to, if you're trying to solve an equation, you are going to simplify until you have a single variable you can point to in the equation. And as soon as you do, then you turn around and isolate the variable by reversing the order of operations. Without even knowing what you're doing, you already do these steps. But I pointed out to you, so if you can kind of, it's called metacognition. You can kind of see inside your brain what's going on. It makes it easier to take this process and apply it later in the year when you're doing stuff that's a lot harder, like solving radical equations. Okay? So let's take an example that you already know how to do. Everybody knows how to do this. But I want to show you what you're actually doing when you solve this. What would you do first? Distribute. Yeah, you distribute the 7. Here's why you're doing that. How many variables do you see up there in that equation? There's 2, right? There's 2 x's up there. So because I've got 2 separate x's, I can't isolate the variable yet. So we've got to simplify. I don't have a single variable, so I have to be moving down my order of operations tree. Well, let's go through the steps. Inside the parentheses, I have an x minus 6. Can I simplify x minus 6? No, they're not like terms. So we can skip through that step. There are no exponents, so I can skip through that step. What's the first thing I see? Multiply, divide. Well, isn't that what you're doing when I distribute the 7? I'm just multiplying the 7 by the quantity x minus 6. So the first step you would do is actually you're simplifying by multiplying. Okay, so let's do that. If I distribute the 7, what do I get?
7x.
Minus 42, good. Equals 10x minus 78. What would you do next? Okay. Now I like to talk about it kind of visually up here with an equation. Where do I want to push the variable? Do I want to push the variables to the right or to the left? I could go to the left. I could.
To the right.
Probably to the right would be a little easier. How come? Then I don't get a negative coefficient. I get more x's on the right, so let's push them to the right. Okay? So we'll, and what is that? Well, that's just add, subtract, right? That we're still simplifying. So if I subtract 7x from both sides, the 7x's cancel on the left side, and I just get a negative 42. Over here on this side, I get 3x minus 78. Good. Now look what happens. We got to the bottom of the simplify part, And what do you know? I've got a single x that I can point to, right? So now all I've got to do is isolate that. Well, to isolate it, we're going to reverse the order of operations. Well, what's the first thing I would do to continue solving for x now that I've got a single x? You'd add 78, right? And that makes sense because we start with add subtract. So we add 78 both sides. And the 78s cancel, and you get 3x equals, what, 36? Okay? And then what's next? Yeah, you divide by 3, because multiply divide is next. So you divide everything by 3, and the 3's cancel, and you get x equals 12, right? Okay, no biggie. But look what you did. You simplified until you could isolate a variable, and then you isolate, right? Okay. How do I know that I got the right answer? Plug it back in. In fact, that's the job. When you solve an equation, think what you're doing. When you solve an equation, you're finding all the values of the variable that satisfy the original equation and make it true. So to find out if you got it right, you would just plug that back into the original equation. Now I get it that in Moodle, when you're getting practice in Moodle, because you're able to reload questions, you're probably not going to check your work every time. I wouldn't either. You're almost better off maybe not doing that, getting more practice and seeing if you get it wrong, we'll try another one. But you got to be able to kind of separate in your mind. You've got sort of the practice Moodle mode where you don't really check everything, but when you take a test, you want to check, right? On a test, if you get it wrong, you miss it. It points against you, right? So why wouldn't you? Thank you. Okay. So why wouldn't you, on a test, plug the 12 in and see if you got it right? If you get it right, if you plug it back in and it makes the equation true, you know before you even hit submit that question that you're going to get it right, don't you? If it doesn't work, what do? Don't hit submit. Go back and find your error and fix it before you miss the points, right? Real important. You think like that on a test. Okay, what about this problem? I would say this is maybe one step harder. What's obviously harder about this one? Fractions. Fractions really do complicate things. Fractions are just numbers, but they're hard to compute. They make doing math a little bit more tricky, right? For everybody, me included. So would you see that if I were just going to kind of hammer through all the steps we just talked about, I would probably want to, subtract 1/6 x from each side? But I'm going to get fractions, aren't I? I'm going to get fractions all the way through. Every step I take, I'm going to be finding fractions the whole way through. Unless there was a way I could maybe just get rid of those fractions right away to make the rest of the steps easier. Any suggestions? Is there a way to clear the fractions? That's what we call this technique, clearing the fractions. This is a wonderful technique. It makes your life so much easier when you're doing math. What could I do? By which one? You're on the right track. You wouldn't want to combine them first because that involves adding and subtracting fractions, right? I mean, I guess we could get rid of the 7s or something. But really, it's easier for us to isolate the variable first because then we know which side everything goes on. Okay? So think about this in terms of if we have an equation, what are legal rules when we're solving an equation? You can sum it up pretty easily. As long as you treat both sides equally, you're okay, aren't you? Right? If I add the same number to both sides, that's okay. If I multiply each side by the same thing, that's okay. That's a legal step, isn't it, in solving an equation? So think about this now. What could I multiply each side by? And I'm going to have to distribute it through both sides to make all the fractions disappear. Well, I could try 3. If I multiply it 3 through, on this side it's going to be fine, isn't it? Right? If I do this. When I distribute the 3 through the right side, everything's good. 3 times 1/3 is going to be 1. x, and 3 times 3 is 9, but what happens on this side? 3 times 1/6 ends up being what? 1/2. Multiplying fractions is easy. I multiply straight across, right? That's easy to do. I get 3/6, which is 1/2. I still got a fraction in there. So I don't want to maybe multiply by 3. What do I want to multiply by instead? 6 is right, okay? Now, why 6? Not because it's the denominator, but because it happens to be the least common denominator of all the denominators. It's the smallest number that they would all divide into evenly, right? So if I multiply each side by 6, look what happens. It's like magic. When I distribute the 6 through, 6 times 1/6 is what? Yeah, 1, good, 1x. So I'm just going to get, for that first term, I'm just going to get an x, aren't I? 6 times 7, 42. 6 times 1/3, 2. So I'm going to get a 2x, and then 6 times 3, 18. Now that's easy from there, isn't it? The fractions are gone, right? No problem. Now we could easily just push the x's to the right and isolate x. No big deal. You could do that. But the big trick there is clearing the fractions, multiplying both sides by 6 to make the rest of the process easy. Okay, let's try a harder one. Try that. That's pretty ugly. Lots of fractions. Now, can you imagine how horrible this would be if we didn't clear the fractions? This would be a tough problem, right? I'd have to be, what would I do? Subtract 5/8 x from 3/4 x to get some fractional number of x's, and then I'd have to subtract 17/20 from 3/5 and figure out what that fraction is. It's adding and subtracting fractions that's hard, because we have to get common denominators. Multiplying is not such a big deal, but adding and subtracting is tough, right, with fractions. It takes a lot of time. So we definitely want to use our trick here, don't we? But we got to figure out what's going to be the number this time. What's the least common denominator of all those denominators, 8, 5, 4, or 20? The smallest number they all divide into. 40. You're right, it's 40. Now you're smart. You guys are all smart in here. You can find that number. But when the numbers are less convenient, it gets harder to do. I want to show you kind of, I want to focus on the process here so you can do it next time when it's harder and have just as much success. Think about how you do that. The least common denominator just means the least common multiple. So it's the smallest number they all divide into. If I were going to make a list of multiples for all the denominators, think what would happen. So the multiples of 8 would be 8, 16, 24, etc., and so on, right? The multiples of 5 would be 5, 10, 15, and so on. The multiples of 4 would be 4, 8, 12, and so on. And the multiples of 20 would be 20, 40, 60, and so on. There's a lot of numbers up there to consider, but which multiple list is the one we should probably focus on first? The 20, yeah. You want to focus on the 20s because those are increasing by big increments, right? We want to ask ourselves, okay, for the big inconvenient denominator, the 20, what's the first multiple that these other small numbers divide into evenly? It's a lot easier that way, isn't it? So let's try 20. 4 divides into 20, 5 divides into 20, but 8 does not, right? It doesn't go evenly into 20, so I move on to the next one, and 40 works. Everybody see that? So 40 is our number. That's the one we want to use. So make sure you put the rest of the stuff in brackets or parentheses because we have to distribute the 40. Now here's another shortcut I can give you. If I distribute the 40 all the way through here, I'm going to get some pretty big fractions coming out of that. For example, if I distribute the 40 to the 17/20ths, 40 times 17/20ths, that's going to be 680 over 20. Because when I multiply fractions, I multiply straight across. So 40 times 17 is 680, 1 times 20 is 20. Now that's not a really fun fraction to reduce, is it? I mean, I prefer not to, right? When you multiply fractions, remember that you can always cross-cancel to reduce. So when I multiply 17/20ths times 40 over 1. There's an opportunity to make this quite a bit easier, isn't there? 40 over 20 reduces to what? 2 over 1, right? That reduces to 2 over 1. And now if I multiply straight across, 17 times 2 is 34. And look, on the bottom I just end up with 1. So my answer is just 34, right? Now, is that an accident? Is it an accident that it worked out so nicely? No, it's not. Why did we pick the number 40? We picked the number 40 because it is a number that all the denominators divide evenly into, right? So why not, when we're clearing the fractions like this, instead of multiplying first and then reducing and getting these enormous fractions you have to reduce, why not reduce first and then multiply? For example, 40 divided by 8 reduces to what? 5. So just cancel out the denominator and multiply 5 by the numerator. Much easier, isn't it? Rather than having to do 200 over 8, 5 times 5 is pretty easy, isn't it? Right? What do I get? What's 5 times 5? 25, and so I've got an x there too. So my first term is just a 25x. Right? 40 divided by 5 reduces to what? 8. So we'll cross out the 5 and multiply 8 times the numerator. 3 times 8 is 24, right? How about on this side? 40 over 4 reduces to 10. So we cross out the denominator and multiply 10 by the top. So what's that going to give me? Yeah, 30x. And then 40 over 20, 2 times 17, 34. How much easier is that now? In one step, we get this easy equation instead of having this horrible fraction-riddled equation. We have to battle fractions every step, right? Now remember, how come that works so well? Because we picked 40 to clear the fractions. Just in some random, if we weren't clearing the fractions, would you expect that every time things are going to, no, not always. But when you're clearing fractions, it will always work that way because that's why you picked the number, okay? And if we continue with this one, what would we do next? Push the x's where? To the right, good. So we'll subtract 25x from both sides. So the 25x's cancel. I get negative 24 equals what? 5x plus 34. Last two steps. Subtract 34, good. So I get 5x equals negative 58. The last step, divide by 5. So I get a fractional answer, but big deal. I didn't have to deal with any fractions the whole way through it after I cleared the fractions. A lot easier, huh? Okay? All right, I want you to try one of those first of all. Try this guy. So first, you got to find the number you're going to multiply each side by, right? We get an answer? May not be completely done. I bet you're close. Let's touch base with this. So, how can we clear the fractions? What can we distribute through both sides here? Say it again? 72, good. If we look at multiples of 24, they don't, 9 doesn't go into 24, does it? So 48. Once again, 9 doesn't go into 48. But if we jump up to the next multiple, 72, they all go into 72. So that works. Good, so if we distribute a 72 through both sides, how do I deal with the first term? What do I do here? Good, 72 divided by 9 simplifies to what? 8 times negative 1n would be negative 8n. Okay. 72 over 8 is 9 times 1 is just 9. How about over here? What's 72 over 7? What's that reduced to? 12. There you go. So 12 times negative 5 is good. Negative 60, and I've got an n there, don't I? And then 72 over 24, 3 times negative 5, negative 15. There you go. And from there, it's not that big a deal, right? Push the ends. Oh, which way do we push the ends? We could, I mean, either way is going to work. But if we want a positive number of ends, we want to go, what's actually large, what's greater, negative 8 or negative 60? Negative 8, yeah. So we really want to push them to the left, don't we? Okay. It's not the end of the world if you don't. It's going to work either way, but this will be a little bit easier. Right, so the 60 ends cancel. Negative 8 plus 60 would be 52. Now, last two steps to get the n by itself. Good, subtract 9. Good, good, subtract 9. Those cancel, and I get 52n equals negative 15 plus negative 9, or minus 9. Good, negative 24. Last step. Good. So divide each side by 52 to cancel the 52, and so I get n equals negative 24 over 52, which is the answer, but we could reduce that. What's a number that divides into both? 4. Good. So we can divide each by 4, so that's going to give me negative 6 and 13. Whoops. So there's our answer. Okay. All right. So what about one like this? That's maybe one step harder. It looks like it's way harder, but it's not. It's not that much different. The only difference here is I've got a fraction that I need to distribute. So you're probably thinking, oh man, how do we deal with that? But remember, multiplying fractions is not very hard. You multiply fractions straight across, so distributing the 1/2 is really no big deal. If I distribute the 1/2, oops, if I distribute the 1/2, I'm just going to get 1 times 7 over 2 times 8. What's that? Yeah. 7/16 x. Here, I'll tell you what, let's get rid of, this x isn't supposed to be there, so let's get rid of that. If I distribute the 1/2 to the -3/4, I'm just going to get, what, -3/8. And then over here, I don't have to do anything. And now it's a problem like we just did, right? I'll just clear the fractions by finding the least common multiple of all the denominators and clearing the fractions and going from there. So how would, we won't even finish it, but right, the main thing was you distribute the 1/2 first and then you clear the fractions. Right? Distribute any fractions that you need to first, then deal with clearing. So what about this one? What would I do here if I were solving this? Just kind of getting you ready for the homework. Yeah, I would distribute the 15/16, wouldn't I? And when I distribute that, let's just take a quick look at that. When I distribute the -15/16, I can take advantage of cross-canceling while I do that, right? I would get -16 equals, if I distribute, I'm going to get -15/16 times 4/5 cubed. And if I distribute over here, I'm going to get a negative times a positive is what? Negative. And I'm going to get 15/16 times 32/3. So when I distribute, look at all the good stuff that happens. -15/5 reduces to what? Yeah, I'm just going to get a -3/1. And 4/16? It's going to give me a 4 on the bottom and a 1 on top, right? So that first term, when I multiply straight across, I'm just going to get -3 times 1 over 4 times 1. So I'm just going to get -3/4 cubed, right? How about over here? -15/3 is going to give, or I'll just leave the negative in the middle. 15/3 reduces to 5/1, good. 32/16. Yeah, 2/1. So I get 5 times 2/1 times 1. That's just -10, right? And then -16. So that wasn't so bad. Multiplying fractions, not so hard to do, and now I got a pretty easy equation. I could just clear the fractions by multiplying each side by what? Only one denominator, 4. Yeah, distribute a 4 through both sides and the fractions go away, right? How about this one? Yeah, distribute the -1/3 and then clear the fractions, right? Okay, last one for today. What about a problem like this? We call this a proportion. If I have a fraction equal to a fraction, you guys did these a long time ago. Real quick way to simplify these. What do? I mean, you could clear the fractions, it would work. But there's even a bigger shortcut. If I have a fraction equal to a fraction, what'd you do? You guys remember this. Cross multiply. Yeah, if you have a proportion, you just cross multiply. You don't even have to clear the fractions. We would just do that cross product, so that's 7 minus 4 times 3. So let's write that as 3 times the quantity. Did I say 7? I meant Z. Z minus 4 times 3, sorry. Z minus 4 times 3, so we'll write that as 3 times the quantity Z minus 4. And that equals my other cross product, which is 2 times the quantity 2Z minus 7. And then that's easy, right? Just distribute and solve, no big deal. Okay, make sense? Okay, you got 8 minutes. If you want, you might as well jump into the assignment. If you do, I would recommend doing problem 11. in the 1.3 assignment first. If you can do problem 11, that kind of reinforces the clearing the fractions thing. The rest of it's not too bad. So take a few minutes, jump in, see if you can get at least one problem done. Get a little bit of your homework out of the way.